Last year I gave a presentation on our experiences and architecture quality metrics for evaluating blockchains internally in Equinor. This year, I'm here to present all of the things that we have learned since last year. And if you read the news, there is a certain blockchain fatigue out there. People are not, or the hype has quieted down. But at the same time, we see that a lot of small solutions are emerging. A few words about Equinor first. The corporate communications people always want us to put this in. We are an energy company. We used to be an oil company, but now we're an energy company, and we're transitioning into offshore wind and solar and everything. We're a pretty big company in Norwegian standards, but we also have a big international presence. We are the second biggest gas supplier to Europe, and a key contributor to, for instance, the UK now having been without coal or not being dependent on coal for the past week. We have offices all over the world. So I get to travel to many interesting places to do software architecture. Last year, we presented our 6 architecture quality attributes for blockchains. And since then, we have been working with external collaborators and internally, and we have found that our thinking on central authorities that we presented last year, that the avoidance or the elimination of central authorities were central to the use of blockchains. That is not as valid as we thought, because we see now that some of the solutions that are emerging, they have a central authority which might not have the same role as central authorities like the banks have, but there is still there is a role for central authorities in our blockchain thinking. And also about timing and performance. In the traditional blockchain networks, there is a long lag and a pretty heavy performance limitations. But when we do this internally or in more controlled settings, then we see that we can get much higher performance. Of course, we might not need that high performance, but we see that we can get it. So, of the 6 attributes that we presented last year, we see that 4 of them are still valid. 2 of them are at least needs to be adjusted. Also, when I talked last year, I talked about a couple of real-world examples of how we thought blockchains could be used. These are, as I mentioned last year, these are the things that I have been working on. And I'm really, I don't know what to say, proud or enthusiastic about having 2 of the things that I talked about last year, which was handling of bill of ladings and energy origination. They are now launched as real companies. So Vakt, which was the bill of lading company, is now launched as a blockchain company for handling post-trade follow-ups in the liquid oil market. Energy Web Foundation, they are now launching their solution for energy originations, amongst other things. So we're seeing that a lot of the experiments and a lot of prototypes and a lot of things that we have been doing are now starting to become real production systems. And of course, when you talk about production systems and test systems and prototypes and proof of concepts these days, it's sometimes difficult to distinguish between what does going into production mean in a modern setting. But for Vakt and Energy Web and some of the others, what it means is that we have real customers, or I don't work for Vakt or Energy Web Foundation, but they have real customers using their systems to transact. And if you look at the oil cargoes, the value of an oil cargo easily runs into a valuation of tens, if not hundreds of millions of dollars. And of course, if you have hundreds of millions of dollars worth of transactions and stuff on your blockchain platform, then you are in production. That's simple. And of course, we also have inside Equinor, we have something called the Emerging IT Labs, where we continue to run experiments. And here we experiment with technology, but also with business models, where we, amongst other things, try to use blockchain technologies to experiment with new business models that are enabled by these technologies. So, what have we found? Well, one of the key areas where we have matured since last year is our thinking around what we use blockchains for. So, one of the things that we see that we can use it for is to create trust. If you look at Google Maps, or if you look back in the days, I used to travel a lot when I was beginning to work in the software industry. And I went to small cities in Europe, and it was always a pain in the somewhere, because I had to fly to some airport, get a rental car, I had to find a map to take me to the small city somewhere where I was going, and it was really hard. Then came these small GPSs that you could buy, but they were also quite hard because they were always outdated. Usually the GPS in the car is outdated even before you buy it. So they helped some, but not a lot. Now, today, we have Google Maps, and with the EU regulations, we have free roaming. So I can take my Norwegian cell phone and use it as home, or roam like home, anywhere in Europe. And that means that I don't have to worry about these mapping things anymore, because Google handles everything. They keep the maps updated, they give me routing information, they give me traffic information. So I was in a small village north of Paris. My in-car GPS wanted to send me down the highway to the airport. Google Maps knew that there had been an accident on the highway, so they sent me racing through the woods. And I'm quite sure that the farmer, which farm we raced through, 15 cars in a convoy, like in the middle of the afternoon, he was quite surprised by all of the people that Google Maps routed through his farm. But that shows that you can build really small applications on top of a big platform to create a good mapping experience. And I think, and this is my thinking, so I'm not saying that this is the answer, but this is my thinking, and if you disagree, I'd be happy to hear you afterwards. But blockchains can be used as a platform to create trust. Because if you want to have trust in the digital world, there are a lot of hard things that you have to solve. You have to solve things like digital identity, you have to solve things like digital signatures, you have to maintain integrity, you have to have strong cryptography, and storage and networks and all of these things. And in a good blockchain platform, and I'm not going to mention anyone, so you can think whatever you want, but in a good platform, these things are handled by the platform. And then we can build small applications on top of that platform. And the applications might not be end-user facing applications, but they might be a small plugin that you put inside your ERP system or your something, so that you can integrate or interface with a blockchain platform. And that is, for instance, for Vakt, one of those things that they do is that they have this blockchain platform based on Quorum, I believe, that are where all the companies interact, but we still keep our energy trading and risk management systems. It's just that we have these small applications that allows us to interface with this trust platform. And why is this important? Well, because without trust, society breaks down. Trust is what enables us as a society to function. And you might have some risk. I don't know what it is, something you worry about. Something like having all your money stolen, or something like having your house robbed, or something. And in a high trust society, like Norway, for instance, you employ some kind of security technologies. I lock my door, or at least I pretend that I lock my door. And that takes the risk down to an acceptable level. What happens if I forget to lock my door? Nothing. Because everybody assumes that the doors are locked, so nobody goes around checking that the doors are locked, so why do we bother locking the doors? Well, if you didn't, and then the risk goes up again. But if you are in a low-trust society, and this is typically like the internet, then you have to have even stronger and more strict security in place to enable the same trust. So it's not enough to have a simple door lock, because if somebody in Rome learns to pick a lock, that doesn't really in Trondheim, because they pick locks in Rome, not in Trondheim. But if somebody in East Asia learns how to break into crypto wallets, that immediately impacts me, because the internet is global. So that means that from a security and risk management perspective, I have to worry about all the crooks in the world. Which is tiresome. And that means that the security technologies that we apply have to be that much stronger. And one of the key questions that you always have to ask when you're working with blockchain technologies is that, because blockchains are a digital thing, they don't really interact with the physical world. So the question is always, who rides the bike? Because the blockchain can determine for you who owns the bike, because you can have a digital record of ownership on the blockchain, but the blockchain cannot reach, if somebody steals your bike, the blockchain cannot reach into the physical world and take the bike from the thief and give it back to you. You have to have something else. And when technologies discuss this, it's always about technology. It's about Internet of Things, and you have digital locks that enables only the owner to unlock the bike, and you can do all kinds of things with technology, which you can, but there are certain limitations. And this comes back to the general thinking on security, which blockchains are a part of. And that is that when you want to have good security, you have 3 pillars to build upon. One thing is, of course, the technology. And when we talk about security, people talk a lot about technology. But you also have people. People are an important part of the security model, that you, both as threats and as actors. And of course, you have organizations. And these 3 pillars, they offer different things in a security thinking. The organization sets the rules. So that means that my employer, the energy company, they can set certain rules regarding who gets access to a particular meeting room or at a particular piece of equipment or anything. Technology enables us to automate that, because we have card readers and everything. But as we know with technology and rules, we cannot predict everything. So that means that we can use people to add resilience. So the people are there if they are the right people, if they are properly trained, if they have the right motivations. They can be there to add resilience and make sure that the security model does not break down when something unintended happens, or something that you couldn't predict. If you look at most of the major blockchain applications or platforms today, they focus a lot on the technology side of it. There are people and organizations there, but a lot of the technology, they are made to work in jurisdiction-less environments. They are made to work globally, which means that it should work just as well in Trondheim as on the Philippines or in Australia or in the US. But when you do blockchains for companies like Equinor or consortiums of companies, you have the whole thing to play with. We can have totally different ways of putting together our security model, because we can have different rules, and we can utilize people in a different way. And this is where those central authorities come into place, because they can be part of this, and they can be, according to rules that we determine, be part of the security model and allows us to shift the trust model around. Another thing which is with most blockchain platforms is that when you talk about security, you have to talk about security in a timeline. So security is about predicting what can happen. It is preventing those things from happening. It is detecting when those things happen and then responding. And if you look at some of the major blockchain platforms, they place a lot of emphasis on the first two phases, predicting and preventing. They can, of course, detect it, but they have very limited response mechanisms. So if somebody runs off with a lot of Ethereum or Ether from the Ethereum platform, what do? Well, your only option, at least then, was to do a hard fork of the Ethereum platform. But in a corporate environment, you can have other responses. You can have a central authority that can go in and override, or you can write code that allows 8 out of 10 players to vote, and if that vote happens, then you can reverse transactions. There are all kinds of interesting things you can do. And that gives you a totally different security model and a totally different trust model. And this is the first key point that we have learned. And that is that different blockchain platforms have different trust models and different applications of trust. And in our case, or in our cases, we might have other trust issues than what the blockchain platform was set up to handle. So when we look at blockchain platforms, we always look at the trust model and how does that trust model align with our trust issues. And that is also, of course, one of those things that's nice with software. You can always fork it. So we can take like source code and make our own blockchain platforms that are mostly like something else, but where we have done adjustments to the trust model to work with the trust issues that we have. And if you look at things like the central authority, maybe we trust the central authority to do some things, but we don't trust it to do other things. In the big public blockchains, then there are no central authorities, but there are because the developers are the central authority because they set the rules. But still, there are no central authorities involved in the transactions. But we can have other uses of the central authorities where we allow the central authority to intervene when something goes really wrong. They might not intervene on a daily basis or be involved in a daily basis, but if something goes really wrong, they can intervene. They can change the code, they can reverse transactions, they can do all kinds of things because it's just software. Then, of course, there are the issues of security and privacy. And I think that one of the things that's important when we deal with blockchains is that to remember that these are security technologies. They are security measures that are there to create trust. And that makes them different from regular applications because most applications are not security applications. They are there to do all kinds of other things. And that takes special meaning when it comes to evaluating the development teams. Because developing a blockchain application, and not the necessary end-user facing application, but the blockchain interface or whatever, is very different from developing any kind of other application. Because if something goes wrong, it can have pretty far-reaching consequences. And therefore, you need to look at the development team. And if the development team has good domain skills and good experience in security solutions and security protocols for the domain that you're working on, then you'll probably be okay. If they are experienced security designers, you might be okay. But if they are a young start-up company with no experience in your domain, then you have to be really, really, really careful because they are certainly going to make mistakes that are going to cost you a lot down the road. So that is perhaps one of the things that we have learned, is to always look at the development teams. How are they composed? Do they have the security skills? Do they have the domain knowledge? Do they know enough about how malicious actors can exploit the domain to really make good applications. Because it's easy to have some kind of risk model, but it takes a lot of experience to get a good risk model. The previous Pierre, he talked a lot about public versus permission versus private blockchain. So I'm not going to go through this in great detail, but there was a question around the security model. I think one of the things that we have learned is that, so if you're dealing with public blockchains, you usually have only proof of work to work with. But if you work with if you have private, especially private blockchains, then you can have other security models and proof of something. We use proof of authority, which works quite well, where we just go around robin and each of the participants in the network, or a designated set of participants in the network, they approve transactions. And that gives us high performance and throughput, but it also gives a totally different set of risks, because what happens if we as an authority approve a fraudulent transaction? What is our risk in that network? So there are some things that you need to keep in mind, but you still have a lot more leeway in how you work with it. So you can, in private blockchains, proof of authority, proof of stake, some kind of other proof of something, or consensus mechanism is actually, can work quite well. And that, of course, takes a lot of the power consumption requirements out of the equation, because you don't really need the power equivalent of Ireland to run a small proof of authority network. You can do that with a couple of laptops and a good network connection. Which brings me to another thing. And in the presentation, which I assume will be made available afterwards, there is a link to the underlying research paper. But this one was really kind of an eye-opener for me. Because if you want to protect against these 51% attacks, or any kind of attack on a proof of work blockchain, then the cost of defense rises with the cost of, or the value, the max value of the transactions. So if you place really high value transactions on the blockchain, then the cost of defense raises similarly. And that's an oil company with oil cargoes that runs into the tens, if not hundreds of millions of dollars. Then, of course, we want to make sure that nobody can really steal our oil cargoes. And that means that defending against that in a proof of work blockchain, that's really expensive. And that influences all of the other transactions on the network as well. So if we were to put our $100 million transactions on the Bitcoin network, depending on how you configure everything, but the cost of the transaction cost for all the transactions on the network would be something like $10 million. And who wants to pay $10 million in transactions fees to buy a $2 cup of coffee? Nobody. So that means that as in a network of high value transactions, low value transactions become really expensive. And this is something that we have to keep in mind when we're working with it, because you have to make sure that the security model is resilient enough so for the transactions that you intend to put on the blockchain. Maybe not on the Bitcoin network, because the Bitcoin network is quite hard, but it only takes a couple of $1 billion to take over the network. It's not that hard. And if you are a big criminal organization or something, or a big oil company or a big something else, getting $1 billion to do something malicious it's doable. I'm not saying that we're going to do it, but you need to keep in mind the transactions and the transaction cost. Because if we try, of course, if we really put our transactions on there, the cost of attacking it would be much higher, but that would also influence all of the others. There was a question about 51% attacks. There was a 51% attack against Ethereum Classic a couple of months ago, I think now, where somebody managed to get enough hashing power to actually take over the network. And that's what we're defending against. Because it has to be so expensive to run a 51% attack that you can't really do it. And that makes a lot of difference to the transaction price. This one should be obvious. Never trust the blockchain that rolls its own crypto. But I have lost count of all the companies and other startups that have come by and said, yeah, well, we've solved the Bitcoin performance problem by rolling our own crypto that we can't defeat. And we know this is security. So we never trust a blockchain that rolls its own crypto. So that's a thing you have to be careful of. And you have to pay attention, especially if you are into some of these startups that run their own blockchains and build their own blockchains. You have to pay attention to how they do their crypto, because it's very easy for them to make mistakes. And that mistakes, they will cost. And if you are in a good legal jurisdiction, then it's fine, because you can always have some legal back work that allows you to unroll and re-roll and do whatever. But in the big public blockchains, or if you don't have the legal jurisdictions, then you have to pay real attention. And this is why blockchains for corporations are very different from blockchains for general public consumption, because we can have all kinds of legal work in place that allows us to protect ourselves against all of the things that happens that can go wrong. And I think that's also why a lot of the adaptions that we see, they have a strong end user license agreement. So you have to be part of it, and then you have to have some way of enforcing it. Okay, so that was the security part. And I know that I'm the only one standing between you and lunch, so I'll try to be right quick about this. We also have some experiences with smart contracts. Yes, last year we talked about how smart contracts needed to be small and manageable, and that still works. What we have learned since then is also that blockchains allows you to look at the world in a new way. It gives you new opportunities to achieve the trust that you need to achieve. And sometimes when people come in and talk to us, we see that they try to re-implement old bad habits on a new technological platform. Because you have some old stuff, and then you try to put the blockchain in there. But the blockchain gives you new opportunities. So you have to make sure that you focus on the interaction. The smart contracts focuses on the interaction between all the actors, like to secure information, or to secure the information exchange, and to secure the handling of ownership. Those are the key things that we find that we need to focus on, and that's what we use the blockchain for. We don't use the blockchain to do reporting or all kinds of other things, because there are much better technologies for doing that than blockchains. And also, when this was an experiment that we ran in the labs, where we see that if you want to do something like know your counterparty, which is an essential part of the EU financial regulations, that you have to know who you're dealing with. And today, that's a very expensive and time-consuming process, where you have to do all kinds of verifications and stuff. But blockchains enables you to actually do that in a totally different way. But you have to really sit down and think about what kind of capabilities do you have that allows you to do this in a different way, not re-implement the current know your counterparty process, but do something completely different that can give you great benefits and cost savings. And since we're still working on it, I will tell you in detail how it works. But there are some interesting opportunities there. So what we learned, said it last year, still applies. Keep smart contracts small and simple, because they quite quickly get complicated enough. But let the blockchain client handle complexity, such as transformations and verifications. And this is because when you look at the smart contracts, they are out there forever. Once you have them there, they are there. But the blockchain or the client, you can update. There is no, you can run regular software development practices on the client, but not necessarily on the smart contracts. A blockchain is the world's most expensive database. So you should use it sparingly, only for the things that you really need for the transactions to be validated. And you can do all kinds of other things with it. You can run through and do stuff, but use the blockchain only for the small things that you need for the interaction to work. Don't store documents on the blockchain. Don't store everything there. Only store the things that you need. Because it is incredibly expensive, at least the public ones. If you do a private one, then of course the whole thing changes a lot. But if you use the public ones, then it becomes a really expensive database. Yeah, and a smart contract is fire and forget. Once it's out there, you can't really tamper with it, or you can't change it, or you can't really do with it. You can publish upgrades to it, but that will only apply to new transactions. So that means that even from the beginning, you need to build in such things as upgradability, which is hard to do. You can do pausing so that if something happens, it pauses for a while, and even have kill switches. We have run some experiments in the labs where the smart contracts, if something happens, the smart contract dies. And that's really useful, because that means that worst case, you can actually you can reverse and you can do all kinds of interesting things with it. And if you have a central authority that you trust or something, or that you use, then you can build features into your smart contract that allows the central authority to intervene. And you can even say something that, like, the central authority is not allowed to intervene until 80% of the authority nodes vote yes. So you can have quite complicated compliance rules in there, but you can still put them in there. Aim for 100% test coverage on your smart contracts. In the beginning, when we talked about smart contracts, they were so difficult because it's hard to test them and so on. But when we've been working on this on the labs, we found that you can easily, or not easily, but you can get quite good test coverage, and you need that because you need to be able to test your smart contracts properly before you launch them. So, and the test coverage is not necessarily there for the same purpose as with other tests in regular software development, because the tests are there to handle change. But the tests are there to force you to think through what is acceptable behavior and what is unacceptable behavior. So the tests are not there to be able to enable you to handle change, but they are there to force you to think about behavior. And that's why you should aim for 100%. Maybe you'll never need it, we don't know, but at least it forces you to think about it. And this is maybe a bold statement, that smart contracts are not software. But of course they are. I mean, it is software, and it gives all of the beautiful possibilities of software. But at the same time, you can't think about it as in similar ways as you think about regular software development, because you can't really do upgrades, you can't really do patching. There are a lot of things you can't do. So when you design and release your smart contracts, you need to think about it as hardware, as unpatchable hardware. So it needs to be really good before you launch the first version. Then, of course, you can do upgrades, but the first version still needs to be really good. So if you bring the traditional mindset of continuous delivery, continuous change, continuous refactoring, and all of these things to your smart contract development, then you're in for a world of pain. So you have to think about it as hardware. Your mental model needs to be hardware, even though it is software. Okay, so what have we learned? even though the hype is over, people are not talking about blockchains in the same way yet. Still, there is a blockchain fatigue out there, but we're seeing small solutions starting to emerge. So, and we're seeing that when we apply the criteria that I described last year to the problems that we're trying to solve and using the right trust model, yes, it actually works. We see the Energy Web Foundation, the VACT thing, they both show that used correctly, blockchain can really give you great benefits. You need to pay attention to the trust model. If you don't, then you're going to get burned somewhere. And especially pay attention how it works with jurisdictions and resilience and the use of central authorities in these things. Because if you run private or permission blockchains, you have a whole different set of trust mechanisms you can employ, and that gives you much bigger flexibility on how you want to deploy your blockchains. Be very wary of small, inexperienced teams, and I don't want to get out here and be labeled as a startup killer, because that's not what I mean. But I mean that if you are a startup, if you're intending to get into the blockchain space in a particular domain, then you need to have people with you that are experienced in your domain. So you can't be like a bunch of recent university graduates putting together blockchain software for a high-risk domain. You have to have somebody that knows what they're doing. And of course, don't solve everything on the chain. This chain is there to secure the information or to secure the interchange and all of these things. It's not there to solve all of your problems. They can be solved somewhere else. And last but not least, security, security, security. Blockchains are about security. Think of it as security and use all of the things that we've learned about security software to work with it. Thank you.